Hey everyone, in this video we'll be going over how to use fundamental trig identities and how to solve problems. So to solve problems like the ones you see in front of you here, there's a few fundamental rules that you have to know, and it'll help you, and knowing these rules will help you approach these problems in a certain way. So the first set of these problems shouldn't be anything new. The first set of these rules would be the reciprocal. So these are the reciprocal rules. So the first one would just be cotangent x is equal to 1 over tan x. Then secant x is equal to 1 over cos x. Then cosecant x is equal to 1 over sine x. So it shouldn't be anything new, but those are just basic rules that you need in order to solve these problems. So secondly, and probably more important, so the second set would be Pythagorean. So Pythagorean rules. So this is similar to the Pythagorean theorem, except it's using trig properties and functions. So the first one of these would be cos squared x plus sine squared x is equal to 1. Then the second one is 1 plus tan squared x is equal to secant squared x. And then finally, we have cotangent squared x plus 1 is equal to cosecant squared x. Now, those can be rearranged, so each of these formulas can be rearranged to form a new equation. So there's a ton of equations, but this just gives the general ones. You can reorganize it, so such as, for example, you have, let's take the second equation. You can reorganize it so it's tan squared x is equal to secant squared x minus 1. So you can swap it around depending on your problem. So those are the main things that you have to know, and it would be helpful to memorize them, but you don't have to. So let's just take a look at our first one here, which is number 9. So we have 1 over secant x plus 1 minus 1 over secant x minus 1. So when you see a problem like this with two separate fractions, and you want to see if you can combine like terms. And here you can't, so we'll go ahead and start by making it the same denominator. So we essentially multiply this side by secant x minus 1, and then this side by secant x plus 1. So you're just making it so that the denominators are now equal. And remember, whatever you do to the bottom, you also have to do the top. So secant x minus 1 times, and then this side is secant x plus 1. So now let's rewrite our new equation that we got after making the denominators the same. We now have secant x minus 1 over, and secant x minus 1 times secant x plus 1, you just, distributive property, you would get secant squared x minus 1, and then minus secant x plus 1, since you're just multiplying by 1 on the other side, and then divided by, so same thing here, secant squared x minus 1. So now, as you can see, we have the two of the same denominators, so now we are free to combine. So now let's rewrite our new equation is equal to secant x minus 1. So this would be minus secant x plus 1. And this is all over secant squared x minus 1. So now we use the distributive property. We take that negative, and we can just distribute this negative to both those sides. So now our new equation is equal to secant x minus 1 minus secant x minus 1. So now over secant squared x minus 1. So now this brings us to secant Oh wait, so the secants would cancel out here since it's positive and negative, and then you'd end up with negative 2 over, because the minus 1 is negative 2, over secant squared x minus 1. So if you're getting ahead here, you might have already noticed that secant squared x is one of our Pythagorean properties. So if you look, we have 1 plus tan squared x equals secant squared x. So that's the only Pythagorean identity that has secant in it, so we already know that that one is applicable. And we notice that it's secant squared x. It's not just normal secant. For the Pythagorean properties to actually work, it needs to be a squared. So you can't miss that. It has to be squared. So if we look here at our second one, if we manipulate our equation to make it so that it's secant squared x, if we take that 1 and bring it over to the other side here, if we take this 1 and bring it over to the other side, we get tan squared x is equal to secant squared x minus 1. So that secant squared x minus 1 is equal to tan squared x. So we can break that down in our equation here, is equal to minus 2 over tan squared x. But there is one more final step that you have to do, and this might be sometimes a little tricky to catch, but the final step we have to do here is we have to convert this into, let's just bring that over here, so minus 2 over 1 times 1 over tan squared x. So that's essentially just the same thing. But what you can see from this is that 1 over tan squared x can break down, comes from right over here. So this is equal to simply minus 2 cot squared x. And that is our final answer. So as you can tell, we split it into 1 over tan squared x, and 1 over tan squared x is just cot squared x. You can just assume it's 1 over tan x and then just add the squared. And then we just kept that minus 2, so it's minus 2 cot squared x. So now let's move on to number 11. So we have, for number 11, cos to the power of 4x minus 1. Now the first step, when you see that anything with something like a parabola sort of equation, or like with cubed or anything higher, you want to try and break it down into squares as much as possible. So when you see this, so we'll just try and break it down into squares. So this just becomes cos squared x plus 1 times cos squared x minus 1. So that's what it breaks down into. And now we can see that there are squares in our equation. So let's go to our Pythagorean identities and see if anything matches. So we have cos squared x plus 1. Let's look at our first one. Let's look at our first one here, because that's the only one that deals with cosine. It doesn't look like we can make anything plus. So we can't make it 1 plus cos squared x. You can only make it 1 minus cos squared x or cos squared x minus 1. And that just segues into our second part of the equation here, cos squared x minus 1. Now, what might be tricky about this is that you see that if we bring that cos squared x to the other side, you get sine squared x. So you get sine squared x is equal to 1 minus cos squared x. So we just manipulated that equation and brought the cos squared x over to the other side. But none of our breakdowns here have 1 minus cos squared x. Instead, we have cos squared x minus 1. But one thing that you can do with this equation is that you can bring in a negative. So now we can change this into minus sine squared x is equal to minus times 1 minus cos squared x. And what that does is we get minus sine squared x is equal to minus 1 plus cos squared x, which you can see is the same thing as cos squared x minus 1. So we actually manipulated it to get that formed. So instead of just sine squared x, it's actually minus sine squared x. So let's write down here, this is actually just minus sine squared x. So now let's write that down. as cos squared x plus 1 times minus sine squared x. And this is actually our final equation because this cannot be broken down any further. So this is where I'll conclude this video, and in future videos I'll go over the rest of these problems in this packet. So thank you for watching. Be sure to watch out for future videos.